Hey, welcome everyone. This is Robert Hurlbut, and I am the founder and leader of the Boston.NET Architecture Group. We've been around now for over 20 years, at least 21. I think we celebrated in December. And in particular, we focused on a lot of architecture, as you can imagine, topics, but also a lot of .NET, a lot of topics over the years at different times, and been also at different locations. We've been remote or virtual, if you will, for at least a number of months. So we did during the pandemic, and we're back here again uh, over Zoom and meeting with our folks in the meetup group. Today is February 19th, 2025, and we have a special speaker tonight. Jim Wilcox is going to be talking about Module-lithic Applications with C Sharp. This is a talk he's going to be giving at the Boston Code Camp 38, which happens on March 29th, 2025. It's a Saturday. It's a free conference if you're interested. It is an in-person conference, so it is primarily for those who are in the area. Some folks may be driving in from other areas around New England or outside of New England. Certainly welcome to attend. But we really appreciate Jim joining us tonight, presenting this ahead of time so we can take a look and learn this interesting topic and appreciate it. So, Jim, turn it over to you. Thank you again.
All right, thank you. I really appreciate it. This is first time I've done this talk branded as Module-lithic, and I kind of owe that moniker to a colleague of mine that kind of coined the term, but really just kind of fits. Appreciate you all coming out here and joining me for it. And why is it not advancing? There we go. So this is, kind of what we're, going to be going through. I do intend to tweak this a little bit before Boston Code Camp, but for the most part, this will be more or less the rundown and all that stuff. We'll do some introductions and talk about, risk management and dependency injection, which is the crux of the whole concept, and that sort of thing. We'll do some demos here too. So again, I'm Jim Wilcox. I'm a Microsoft MVP in developer technologies. Very, very honored to be so. I got a great family that we got to go to visit London this past summer, so that's a picture of us there. I also chair organized Granite State Code Camp, which is it's very inspired by Boston Code Camp. I also do a every weeknight at 9 p.m. and you're all officially invited if you want to come. We'd love to see you. A thing called Granite State Code Review Nightly. It was supposed to be literally 2 weeks to flatten the curve, but somehow it just keeps on going. It's a little bit like the Energizer Bunny. I have always said as long as people keep coming, we'll keep doing it. But it's an hour every night at 9 p.m. after the kids go to bed and all that stuff. We can kind of get together and just talk shop about whatever folks have going on. And sometimes it's actually like, trying to help somebody debug a problem or come up with a reasonable solution. We'll help people decide, how they want to term a statement of work, or help them polish a presentation like this one. Whatever you got going on, it's kind of a box of chocolates, but you never know exactly what you're gonna get, but it's usually pretty cool. And I also have a book. It is not a technical book. It's called Faith Hacker. If you're interested, you can check that out. Otherwise, but so I usually like to ask a little bit about the audience here, and I do definitely appreciate having an interactive conversation. You're certainly welcome to come off mute and ask questions and make it a two-way conversation more than just a dropping content and stuff like that. So just curious, and I've been asking these questions for a long time. So some of them, are a little potentially obvious. I'm guessing most of us here are C# developers. Um, Probably plenty of us web and web API and that sort of thing. I won't make anybody raise hands to identify themselves. But so I guess I will move along from there just based on the sort of obvious topic at hand, the .NET Architects group. So I like to talk about software development as an exercise in risk management. It really is fundamentally so. And I tell people, I put it up here. If it was so ubiquitous, so well known, so unlikely to change, low risk, why not build it in hardware? But that's not what we're here to do. We're here to look at building our applications and application architectures and that sort of thing. And that, of course, is also kind of what solid principles are designed to help address, especially the risk of change. That's the big thing. Everything about software development, from the way that we develop it, agile methodologies, all of the tools that we use, all of it's subject to change. And so the things that we build should be fundamentally aware of the risks of change as well. And this is a concept that this particular talk around this module-lithic concept was all about modernization. I do consulting for rather large organizations. Lately, it seems like I've been doing a lot of grocery stores, grocery store chains. I'm currently wrapping up actually my third grocery store chain of the past few years. But as you may or may not be aware, a lot of them have been around for a long time. A lot of them are built on very old platforms. Tons and tons of things like good old-fashioned COBOL and C++ here and there for the people who got really adventurous back in the late 90s. And that kind of thing. And so it's a lot of modernization and some of the challenges that they have, in modernizing an application. Let me stay on the slide. It has to do with all of the interdependencies of an application, and so that's where some of this fits in and sort of where it came out of. So of course, as far as the solid principles themselves, I'm sure this group is very familiar with all this stuff. It's funny because occasionally somebody actually asks me what the acronym actually stands for, and it's like it's kind of so ingrained that I tend to forget what the letters actually represent. It's just kind of part of the language in and of itself. But of course, the solid principles, the idea that everything is a single responsibility, it has no other purpose other than to do the thing that it does, and that means it's small, it's testable, it's easy to work with. Open close principle, it's open to extension but closed to modification. So you can always count on your objects to do the things that they claim to do, and that's part of the process. The Liskov substitution principle, named for the woman who sort of pushed this forward, the idea that your data objects should be substitutable, especially in terms of inheritance. So if you have a data structure that represents a generic structure or concept or domain entity. And then you extend it, the extension still works as the original. Same thing with the interface segregation principle, the idea that you can create an interface that doesn't by itself have any particular functionality. And dependency inversion is, the idea that you sort of hand off control more or less of your execution to a dependency that you don't necessarily need to know exactly what it is, but it knows what it needs to do based on the contract of your processes and that sort of thing. Any questions? I mean, this is kind of, basic, relatively speaking, but I know especially for this group, for Boston Code Camp, it'll probably get a little bit better mileage, but so as far as dependency injection itself, so understanding that you have the idea of inversion of control, you have your interfaces that are abstractions of sort of the big picture steps, the things that you need to operate some unit of code or manipulate it, however you want to put that. But so the interface is the thing that you build your application against, and then you have, of course, ideally a decoupled implementation that actually does the job, and that's the inversion of control, in the sense that the interface by itself doesn't do anything, and you don't necessarily care a whole bunch about how the implementation does the work, but you hand off that execution to the implementation. It uses whatever dependencies it needs to get the jobs done, or job done, I should say. And with that, you have the opportunity for multiple, and I think what I meant to say here was multiple implementations. So different implementations might have different dependencies. You might have a implementation or interface that describes a contract for saving content of some sort. And one implementation might save that content to a file structure, another might save it through a third-party web API, and you might have another implementation that saves it off to, say, a database. Now, in classic terms, dependency injection is a great way to modularize your application. It's not a silver bullet for doing that, and it is sometimes relatively difficult to communicate what dependency injection is to your development team, who may or may not have as much experience with these terms and capabilities. But once you develop a little bit of groundwork, a little bit of platform engineering goes a long way in terms of making your implementations into effectively modules that you can then use dependency injection frameworks to configure. And so, like I say, it's not a silver bullet. It's literally by definition abstract. But it's definitely worth digging in on, and we'll talk a little bit more about this. So this slide is primarily, actually, before I move on, that was a little bit of a hefty lift. I do kind of get into some examples here, about dependency injection and interfaces and stuff like that. But any questions before I I move on. All right. So again, this is, sort of for the not necessarily architectural crowd, trying to help understand what service interfaces represent. And so the idea that I'm trying to get across here is that if you have a thing called a house, for example, physical house in the real world, there are lots of things that you might sort of anticipate that house would have. It's sort of capabilities and stuff like that. It would have, it'd probably be heated. It might have air conditioning, which I'm surprised I didn't put here, but it was getting cold. Water, of course, septic disposal, electricity, telecommunications, all of these different things that are sort of a part of the common, what we think of in our society as a house. And so these are services or interfaces you could think of as things that a house sort of consumes to make available to the people who inhabit it. And so all of those things might need to be provided for by external providers. For example, your external providers for the water service of the house would be maybe local well water or town water or something like that. But you don't really care where the water comes from as long as when you flip on that faucet, the water comes out and it goes down a drain and goes out a septic system. So that's sort of two in one there. And then there's other providers for other services, where you get your maintenance stuff, where you get your your lawn care stuff, where you get your fuel for heating and electricity and connectivity and all that stuff. So this is trying desperately to make clear what the abstraction of an interface is, and then make it a little bit more concrete in terms of what a person experiences in a physical setting, sort of outside the software development world. But of course, in an actual application, we're talking, there's lots of different things that you can expect an application to sort of manage somewhere on some level. These are all different things that a typical enterprise application might have interfaces for. Not necessarily all of these, but just various different things. And this doesn't even necessarily talk about bespoke applications, bespoke processes and all that. These are just things that you might want your application to have as part of its platform. So you might probably have some kind of transactional database or some sort of authorization service or secrets management. Might have machine learning models associated with it. Different types of logging, auditing, observability type things, images and all that stuff. Just things that the application might sort of provide to its developers while they are building out their applications. And again, these are just sort of contract capabilities that that a developer might have an interface for. And in .NET we do have a good number of things like the good old iLogger and trying to think of what else is. There's lots of good interfaces that are relatively common to the .NET world that we're all relatively familiar with. Any questions there? All right. So, this is where I start getting into the whole comparison with microservices and that sort of thing. So you want your microservices to have a well-known interface, single responsibility, relatively decoupled dependencies from the rest of the system that it supports, ability to reuse common dependencies, and you don't have to necessarily read all of these bullet points here, but you sort of get the gist of it. And microservices have become a very popular architecture style, and they've sort of kind of come into popularity, sort of an extension. I think I want to say that they were sort of an evolution of services oriented architecture, in the sense that you could publish a microservice that did relatively straightforward, like CRUD operations on a domain entity, or that kind of thing, relatively simple, simple responsibilities that could then abstract how it does that stuff from the rest of the enterprise fabric or application platform. And so as time has gone on and people have sort of experienced microservices and stuff like that, it's sort of popularity for it for people who have actually done it, it's a fairly operable thing, but for a couple of classes of developers, there's people who have never really actually done microservices. They've always sort of done things they called microservices, but they were actually maybe a little bit more domain services or something along those lines. They might have taken care of a range of different entities. And there sort of became a number of issues with that, in the sense that microservices are well, let me stay on this slide here for a second here. Among the favorite little quips that I've seen about microservices, they're fun until you realize that they're kind of, when something goes wrong, it's a little bit of a murder mystery. If you have your observability set up right, maybe you can do something relatively quickly, but it's definitely understandable that in a distributed platform like microservices, you run into lots of different issues about versioning your microservices and making sure that you're able to trace through them as you're debugging, and dealing with all of the different surprise things that might occur as a result of not having the microservice that you expect to live where it is living, and be hitting it when you're not expecting to, or not hitting it when you're expecting to. And so you get to deal with certificates and authentications and all of those different things that actually turn out to become application risks, that kind of go away if you start looking at a module type architecture, where now we're talking in a monolithic application, you kind of do away with a lot of that cross-process handshaking and configuration and all of that sort of thing. You don't necessarily need to worry about, configuring message services and, all of the queuing that might go with it, or making sure that your SSL certificates are configured properly and all that. But unless you go with something like a module-based approach, you lose that ability to be agile. And that's what we're trying to maintain, is kind of going for a best of both worlds with this sort of module-lithic approach, where it's all primarily based on interfaces, and is all about, making it so that you can literally trace through your modules and have your dependencies in process without necessarily being tightly coupled to them. And so of course, easily compiled for type checking. It avoids that murder mystery thing that I was talking about. You can trace through your execution paths and all that stuff. And yes, it does take a little bit of teaching to your dev team. You have to show them, how to architect the application in terms of decoupling your dependencies through your interfaces. But that's part of what we'll be taking a look at here too. So any questions to that point? All right, moving on. So basically again, the whole reason for this is, if you imagine in an environment that maybe was originally put together, maybe back in the 2010s or something along those lines, and they're desperately trying to modernize things, but they've run into dependency gridlock. That's a real thing for a lot of major enterprises, that they get into this situation where they are so tightly coupled to their dependencies for various reasons that they actually have a really serious hard time getting past it. And what you end up doing is sort of taking it one little piece at a time, taking the things that you can control relatively easily, and swapping the implementation, modernizing that one little piece. But that means that you've got to go back and modernize another piece later, maybe after you've built your bespoke application. And of course, that's again where these ideas of interface bound modules come into play, is the idea that you abstract away that specific implementation and make it so that later on down the line, when you know that your database is going to go from some COBOL flat file thing to a new relational database table, you can swap out the implementation for it, just based on the dependency of flat files versus SQL Server, for example. And the interface will still work. You can build your application and your modules, your implementations to be fully testable against that interface, and in theory you should be able to test every implementation against its interface without necessarily knowing what the implementation is. And so these are like, the confusing, sort of looking enterprise roadmap concept that, one implementation might get changed out for another, and from Q1 it was this, and Q2 it was that, and Q4 it's going to be this other thing, and your application really needs to be able to swap out those kinds of pieces. And so so a lot of folks have probably worked with things like AutoFac and other sort of dependency injection tools. I rarely run into a dev team that really actually does dependency injection correctly. Most of the time, what I see when I go into a new client is, if they're using dependency injection at all, they have a bad habit of more or less compiling the dependency injection configuration into the application, which basically means that if you want to change any of the implementations, you have to fully recompile and rebuild the application, and you can't just swap out necessarily at runtime. Also, there's a couple of interesting challenges in .NET. A lot of what needs to be done for dependency injection configuration gets done before your builder.build call. And that's, absolutely, reasonable. No problem with that. The challenge that you have is then setting up your pipeline, and basically what I mean by that is, say for example, you want to use a Redis cache for your caching implementation. Oh, it's a fun one. iDistributed cache. You have an iDistributed cache interface in your application that you want to take advantage of. And you don't necessarily want to tightly couple the actual implementation into your application. But that application still needs to trigger the initial connection to, say, for example, your Redis cache. And that might be a little bit different from a case where you just want to use like a memory cache, which you can also do. You can actually in .NET there is an implementation of iDistributed cache that just has a memory cache behind it. In the case of the memory cache, there's nothing else to configure. You wire up the dependency injection container with your memory cache, and you're good to go. In the case of a Redis cache, you have to wire up the dependency injection container, but then you also have to initialize the provider. So you sort of configure it, you have to get the connection string to it, and establish the connection to the Redis host, for example. And that's extra stuff that you don't necessarily want to have to compile into your application. So that's where I ended up building a little bit of a framework that makes it relatively easy for developers to, first of all, modularize the dependency container configuration, and then in a separate call actually do any additional service initialization, like in that particular case for the Redis cache. So again, all of the things that you do in the configuration step in your typical program.cs that you do for the stuff before builder.build, but then there's those extra things that need to be done separately and after the builder.build call. And so that's a little bit of a challenge in trying to build a .NET application that truly um, cleans up your dependency leakage, because it's just so easy for a developer to just tweak program.cs or something in that call path that configures your Redis cache. And so at this point, I'll get into my code demos. Any questions so far? I know that this is, I'm trying to not just make this something for an architectural level discussion. I really do like, trying to get, developers to get involved in these types of abstractions and making sure that the dependencies are decoupled. But I understand it's not necessarily an easy thing to talk about because it's literally abstract by nature. So any questions at this point? All right.
I got a question.
All right.
So can you go back to the previous slide?
Yep.
Yeah, this one. So you mentioned that. So I think I'm one of those people who always use dependency injection pre-compilation way. So I always compile my all of my dependencies, and I couldn't understand. I mean, so yeah, it is interesting for me to hear about about dependencies being able to be injected after compilation time. I could not understand. So, can you open that up?
Yeah, actually that's the demo will get into that a little bit, but uh trying to make it a little bit more concrete. But yeah, you actually can, as long as you build your implementations in a way that are binary compatible with the interface, you actually can load those assemblies at runtime and have them configure themselves to be the implementation for specific interfaces. And so by doing that, you totally abstract the dependencies themselves from the interface. So you compile your application only against the interface and don't really care, what's actually servicing those interfaces.
Okay.
So I'll show some examples of the code that I've built.
Jim,
Yep.
quick. So is this using managed extensibility framework that I used like way back when, or is this something that you guys built?
This is something separate. I looked at managed extensibility framework, and it's not exactly this. It's in a lot of ways that felt like it was a little bit more complicated than it needed to be. This is based entirely off of dependency injection and containerization of interfaces and that sort of thing. So in a sense, creating your interfaces that then become the face of your modules. So it's a lot simpler on some levels, and doesn't need doesn't need the traditional extra libraries and stuff like that. You don't have to take dependencies for third-party stuff if you don't want to do this. This is just a little set of utilities that I'm demoing here that I'm actually kind of working toward open sourcing these, but it's when I get to the point where I'm ready to show that library, you'll see it's actually not much to it. So this here is an example of, actually, let me make sure I'm looking at the right things. I'm going to close all these and go back to this right here. So how many folks recognize this? This is probably pretty well recognized. If you
Can you zoom in a little bit, by the way?
Oh, sorry, yeah, it's just a little bit tough to read here. Let me see if I can get as much of that on here as I can.
Maybe a little more. Sorry.
Okay.
Okay, thank you very much.
Is this something out of the box, right? What we get when we create a first API?
Yes, yeah. So if
Rather,
you this may be a little bit dated. It was made during .NET 8 days, and .NET 9 may have new templates, but this is more or less the default template for a particular, just the, when you tell it you want to build an API, it creates this from a template for you, and it just has this cute little implementation that's very basic. This is really untouched. So if I start this, so I'll go ahead and run this one. I didn't mean to switch files here. But I'll go ahead and run this real quick. And pardon me a second, it needs to warm up the caches. And of course, the browser shows up on a different display. So this is my, out of the box API, nothing special about it. It does the thing in a non-injected, no interface, no nothing. It's just as is. So this is kind of the nothing up my sleeves kind of thing. So now I'll go back to sort of the next iteration of this. And set this as the startup project and show off the code. Now, what I've done here is I've cleaned up the program.cs a little bit. There's a little bit less code in here. But really what it's about is I've abstracted out a process called a weather forecaster into its own implementation. So the weather forecaster is still very small and simple. And I've got, that was the weather forecast. This is the data model. I mean, and it's taking advantage of, fancy .NET 8 C#12 syntax with this default constructor, which definitely good reasons not to use these, but that's a story for another presentation. So this is literally just a record. It's a data structure, has 4 different properties, temperature, date, and summary, and all that stuff. It's just an abstraction of part of this. This is the actual implementation, the thing that does the work and creates instances of a forecast and returns them right here. So this is actually developing the forecast and producing it and returning it back to the program, which makes the program a little bit smoother. We're now saying, all right, I've got a dependency here. It is on this weather forecaster. Still no abstraction of the interface. It's literally, this is the implementation for the forecast thing. So, so this actually is, if I run this, it'll do exactly the same thing that we saw the original do. It's just a little bit more cleaned up. this is kind of the state that I see a lot of applications built in when I visit a client site and look at their code and stuff like that. Or something sort of akin to this level of maturity. Any questions so far? So I'll sort of make sense. Now I'm gonna go ahead and get into a little bit of, let me close these out and get them sort of hidden away for now, because this is the one we're looking at. Simple injection. I am going to set this as the startup project. And we still have our weather forecaster that actually looks just the same as it was before, but now I've created an interface for it. Okay, and now the interface hides this implementation. We no longer need to necessarily know that our implementation for iWeather forecaster is this weather forecaster. And so if we go back to our program.cs here, you can sort of see that I'm creating a service here, adding this configuration. This is still compiled in. So we still have a hard dependency on this weather forecaster right here, at least at this point. And this is before the build step. But we've simplified the implementation itself down to, this right here, which there's a little bit of fun syntactic sugar in this one. I use the from services to create this constructor that ultimately just says, give me a new iWeather forecaster. Don't really care that it is or isn't one of these. It spins up the instance for us and allows us to call the forecast method. So again, relatively straightforward, but we're still compiling our dependencies into the project here. And again, still does same stuff. So no real surprises here. And it just does what we expect it to do. But now we'll start getting into the actual modularization of the code here, and I'm going to close these all up and move on to this modular approach here. So what I've done is I've divided the code up into a few different modules per se. We could call them that. So the initial one that our application must take a dependency directly to is the abstractions. So these are the things that, basically are our interfaces. And I played around with adding this, forecast for zip codes and, stuff like that to the interface. But we have a few constants, like, this is like a set of summaries that we sort of expect to provide, across implementations, depends on how they actually get produced. And then we have a data model here, which is the same data model that we had way back up here. And so what this does is this defines the contract for a weather forecast implementation. It's all of the things that your application needs to know to be able to use this interface. But it's all abstracted away. There's no actual running executable code in this per se. It's just the interface. And then we can have different implementations of that. So I created, just for the fun of it, I created two different modules, so to speak, both of them take a dependency on that abstraction, so they know what their contract should look like, and implement it. It does the implementation and basically does the execution. I cheated a little bit for the forecast for zip codes. It really just ends up ignoring the zip code here, but that was a phase 2 feature. So but anyway, this is basically the same implementation that we had way back in the first implementation. This is just going through and spinning up literally new weather forecast and returning it the same way that we did before, except now we've got this implementation set up in a way that we don't care where this came from. This is the same implementation as the original, but we don't need to know, we don't need to care. Our application can actually load up this this assembly after at runtime and figure out that there is this implementation for this this implementation for this interface and load it using reflection if you want to. And so in that way, just using reflection, no additional libraries whatsoever. This is just using software development technique that's built into C#.NET. We've actually got capability of this kind of actual modularization based on an interface pattern. And of course, this means that we can potentially have an enhanced weather forecast implementation. And maybe this is a little bit different because it actually has a dependency on something else. And so using classic dependency injection patterns, you can compose your dependency chains, just like this. So we configure an enhanced weather forecaster for the iWeather forecast. When it spins up an instance for us, the dependency injection framework will discover, oh wait, in order for me to spin up an instance of an enhanced weather forecaster, it also needs a dependency on an iDistributed cache, and it doesn't care whether this iDistributed cache happens to be a memory cache or a Redis cache or a database cache, a file cache. It doesn't care. It's just an abstraction. And you can see what it does here is I built a little, little utility to make this relatively easy. This is my cache key here that says, all right, look in the cache for something with this key, and if you don't have it, execute this and populate the key, and return them. So, okay, basically what we've got here is, basically more or less the same implementation. I could have gone so far as, maybe I'll do that in another presentation. I could have actually pulled in the basic weather forecaster and just had it call the forecast method on it in here, which would have been maybe a little too meta, but anyway. So the configuration for this in our program.cs, now if we look down at the actual modularization application, there's almost nothing in it of its own. All of its code now is in projects, and also understand that these projects could just as easily be distributed as NuGet packages or something along those lines. And so what I've done here is I've made it so that, if this is, a development environment, go ahead and add a distributed memory cache and add the enhanced weather forecaster. And then if we aren't in a development environment, we will not use, say for example, this is a development system. We're actually building a more enhanced weather forecaster, and so this is the implementation we want to use. Now this is still using configurable, arguably configurable, but it's still compiled into the application. There are ways to build out this application so that instead of doing this, it uses reflection to load up the implementation and discover the implementation for iWeather Forecaster and add it to its dependency configuration. I didn't go quite that far with this demo. I will show a little bit of the code for the framework that I've got that does some of that. But you can see that this, depending on the situation, whether we're in development or not, and I'll go ahead and set this as my startup. This is really the only actual file in this project at this point. All of the actual working code lives in other assemblies. So where is my set element still running? What's going on here? So I want to set you as the startup project. And I want to close these and run this. Okay, so I honestly don't remember how I've got this configured right now. Okay, so it is configured as a development environment. And it adds the distributed memory cache because this enhanced weather forecaster needs it. And then we do our build.build and set up Swagger. And now our implementation is literally just load the thing that implements the iWeather forecaster, same as before, and execute it and do this, forecaster.forecast. Okay, and we'll run the application, take a look at it. And one thing that will be different in this execution, so the first time through, it's just going to randomly generate a forecast the same as we're always used to. But let me zoom in a little bit if I can here so that you can see it. First one here is -12 Celsius and it's chilly. Next one is 50 degrees and it's mild. Sounds like some pretty wild weather there, but if we execute this again, because it's cached, using the enhanced implementation, we get the same result. Until the cache expires, of course. So at this point, what we've got is a couple of different possible implementations. The thing that actually executes this code doesn't know or care which of those implementations it's going to get until it actually executes it. And so in that way, we've made it so that this again could be pulled out and reconfigured through some other means like reflection. And so let me bring up that. Okay, so what this library is basically relatively simple. I mean, when I say simple, it's not the simplest thing in the world. I wouldn't necessarily go to a junior developer and say, hey, bang this out for me. It's definitely got a little bit of thought behind it, but the idea is that we have an attribute, and I called them retcons, just because anybody in comic book geekdom will probably recognize the term retcon. It's a retroactive continuity. It's the sort of comic book way of explaining differences in a storyline. And so, you know, comic book stories, they'll tell a story one way, and then later on they'll have a flashback to that scene, and there'll be something critical that's totally different about it that they end up having to explain, that changes everything you thought you knew about the way the story went from the very beginning. And, you know, so like I say, in the story world, that's what a retcon is. And so what I've done here is sort of created the same modules. So my weather forecast abstractions here is the same. My weather forecast classic is, excuse me, the basic implementation, but I've added an attribute to it. And this attribute says this implementation belongs to this interface. And so now you can query your assembly, you can load this assembly up and discover automatically and register this implementation. Now, this is what I call a default implementation. This is the implementation that you'll get if you have no other reason to choose something else, because there's no other qualification on this. This attribute just configures this, and if the retcon composer doesn't find any reason to use a more complicated implementation, it will just use this one based on this attribute. Now, my weather forecast enhanced implementation is, you can see it's got a few more things going on in it here that I played around with. But let me take a look at the forecaster for this. So this is the enhanced implementation, has essentially the same thing. It's a distributed, you know, takes a distributed cache at its construction as well. But this configures a thing called an arranger. The arranger knows that for environments, including development, this is the implementation to use. And so what it will do is the retcon composer will read your configuration, discover what environment you're in, and then look through all of the available assemblies in the current folder and pick the most appropriate implementation based on the information that it has and the results of the arrangers. So this arranger will look at the environment condition. It will say, oh, this is in development environment. We're going to use the enhanced weather forecaster for actual execution. And if we go to our web client API, I'm not sure why that's not set up right here. What did I do? But what this does, this add retcons method, this is an extension. So I think I was messing with the code. I apologize. This might not be runnable, but what this is doing, this little utility is, it is intended to load up all of the assemblies in the application at startup, look at find all of the arrangers in all of those implementations. So the arrangers can be custom. So you can make it decide on which implementation to use based on any arranger that you want to implement. And it will load up your dependency injection configuration. So essentially the whole application is now this line of code and then triggering this implementation. And the other part, if you remember right, the part about what you have to do after the builder. So app dot use retcon target services is a call that also understands an interface within the configuration of your module that knows how to start your, say for example, your connection to your Redis cache, or establish that connection, or whatever it needs to do after the build statement. And oh, I already had that down here. I don't need that in there again. Apologies. So I apologize that I can't run this right at the moment. I really should have made sure that I had this set up to do that, but I think you kind of understand. I am getting ready to try to open source this retcon library because it's relatively small, really provides a lot of flexibility, allows you to create completely abstracted modules for your implementations. You might have groups of implementations in a particular assembly, but this makes it all, relatively straightforward in a way that you can then go back to your development team and say, just put, either a tag like this for your default implementation, and it will always, pull this implementation in. And if we want to get more advanced, we can, start working on your enhanced weather forecaster and configure it this way. Or like I say, we can make a different arrangers that look at different properties of the application or different configuration values and figure out, oh yeah, this is the implementation that we want to actually pull in. And now you've got, like I say, that situation where you have not compiled your dependencies into your target application. So if we look at this, this has dependencies to the enhanced and classic, but it doesn't need dependencies to anything to do with dependency injection. I mean, not dependency, distributed caching, for example. This project has no idea that there's a dependence. I keep saying that. This project, this web client API has no idea that there might be an iDistributed cache involved anywhere in these processes. It doesn't need to know or care. And so, like I say, you've completely abstracted the dependencies of these implementations away from the application without compiling them in. These don't actually have to be referenced. And if you use reflection and load the assemblies at runtime, these don't have to be here. I did that as, I included them here as a convenience because it's an easy way to make sure these assemblies get put into your bin folder when you compile. But otherwise, all you have to do is just make sure that you get these assemblies physically there, and it will figure out which implementation to use. So any questions? I know we're running a little bit up past time here. I don't want to go too much further, but that's basically where this is. So
So aren't you basically compiling in your dependencies, but you're doing it in the configuration project thingy as opposed to like the higher projects in the solution, because it's still saying, this thing that implements this interface, your development environment, and or this other thing. You're still getting the services. You're still reflecting. They're all compiled in the thing. You're still running, it seems, a program CS that's deciding what service it's going to pull in. This thing that yeah, exactly. And that's still a compiled program.cs, right? So is
Yes.
it as abstracted as you think it is, or it's basically that the bulk of your application doesn't know, and this is more of a conductor. It pulls things together.
So this is the great part about this, is that this is the one thing that you have to have in the code compiled in. Well, okay, two things, one before the build structure, the build configuration, one after the pipeline area. But these have no idea what it's going to find. Again, the
Right.
only reason that I have these two pieces in here was just a convenience to make sure the DLLs got copied in. But no, there's nothing here that leaks the dependencies. Like I say, this application has no idea that there's an iDistributed cache involved in this, let alone what the implementation of it will be. And that's the important part. So it's pretty cool as far as absolutely hiding, your actual physical dependencies, your true implementations. In fact, if there's a real criticism to this, and this is valid, it's that you actually will have to be careful about the security of the folder that this application runs in, because all somebody would have to do to get it to run a different DLL is make sure that they have the right interfaces and just drop it in the folder when it starts up. So it's a little bit of a security risk from that perspective. You probably want to make sure that your assemblies are signed and that I'm actually looking at making sure that the code checks the signature for the assembly, and it makes it a thing that it has to match a certain signature or key or something along those lines to be included. So that's a feature for phase 2 as well. But so like I say, it's actually so abstract that it could potentially be seen as a little bit of a security risk.
Well, I think Meth did the same thing. I mean, if it basically finds the assembly, when it needs it, it's like, ta-da, that's what it's going to use. And it feels like you're doing something very similar to it.
Yeah.
Yeah.
Any other questions? Right, so I am kind of gauging interest in what people think of the retcon platform. I have used simpler versions of retcons at other places, with clients, and it was very successful. It was very easy to tell a developer, for the most part, make sure you abstract everything, follow the structure of, your interfaces, your models, your common things like constants and stuff like that. As long as you build out the things that the compiled code needs to know about how this interface operates, this doesn't care, what implementation you use. And then when you build your implementation, put that in a separate assembly and just real quick tag it with this. And on that level, it was actually relatively easy to communicate to the development teams, use this attribute, the retcon library itself will take advantage of configuration in the application and know what pieces to actually pull in and execute. And so at development time as a developer, this is great because now your dependencies are not hot swappable, but they're swappable like a microservice. But you get all of the advantages of developing locally with assemblies that you probably already have source code for. And so when something blows up, the exception actually can potentially pop up directly from the implementation instead of from some microservice that you then have to go spelunking through logs to find out where it actually died. So that's the concept anyway. And like I say, I'm definitely open to feedback. I would love to get around to open sourcing this retcon library, but you don't need it to do the technique that I'm talking about. You can build your own. It's not tens of thousands of lines to build what this does. It's, a few hundred lines of code. So the retcon library itself is actually, relatively small. So.
But Jim, is the big win the assumption that you might have more than one implementation?
Yes.
And if you don't, then
if you don't, it doesn't necessarily matter. As long as you've modularized, so the great part about this pattern is it sort of encourages the developer team to just follow the pattern, whether they actually intend to use it or not. And so what we found was that it was relatively straightforward and easy to get developers to put a default tag on things. And this would just work for the most part. But the nice part about having it tagged with this and pulled in at runtime is that we have the opportunity to swap it out, which makes it super easy to do all kinds of different testing. You can deploy your application to different environments, and each environment can be configured to work with different database hosts, different database services, different web applications, and these are all the kinds of agility features that microservices are intended to help you manage without the super huge overhead of configuring all of those microservices and deploying them all and debugging them all and testing them all and stuff like that. So you kind of get the microservice agility with the local development execution debugging experience and working environment.
Would this allow you to upgrade one of these modules like without shutting down the main application, like sort of like if you were using a microservice?
That's another feature that I've considered, and there's no reason you couldn't observe your configuration and have it automatically reload your dependency injection configuration at runtime. The library that I've built currently doesn't support that, but there's no reason you couldn't.
Cool, thanks.
So any other questions before we wrap it up? Or all right. Well, I really appreciate you coming out. I hope that this was something worth considering for you, and maybe worth bringing to a team or something. And like I say, I'm hoping to open source this as part of Granite State users groups. We'll see. There's some tricky details. There's sort of some details that I have to work out. But again, you know, the pattern, the capability, all that stuff is mostly built into .NET C# as is. You don't have to use this library to take advantage of it, and it's sort of a capability that we neglect or forget when we're building our application, when we're architecting our applications. So with that, I will thank you again for coming out. And one other thing that I'd like to add, if you'll humor me a little bit, I am actively seeking a new role right now. So if you happen to know anybody who's looking for, you know, somebody to help dev teams figure out stuff like this, please, you know, let me know, and I appreciate it.